Alright, just gonna test out my audio real quick, make sure everything's working right. Alright, just gonna test out my audio real quick, make sure everything's working right. Alright, sounds good. Just gonna okay. So, hello. I decided to go back on what I was doing before because that's not really what, this whole thing was going to be about on this channel. So I've decided to start my next project, and it actually took me quite a while to figure it out, but I think I'm going to go ahead and try making a 32-bit CPU emulator in C. Now this is going to be completely custom because I think that other architectures are kind of dumb. I already did this for a 8-bit CPU. I don't expect this to be quite as easy. I do want to make this much more simple than other things, so I'm just gonna go ahead and get right started. So first things first, I'm going to make the source and then build folders. And then I guess I should also make a bin folder, because this will have the outputted program. Oh, no, not a folder. New file. And then let's just call this emulator.c for our main one. And just to make sure everything is working properly, let's do a simple hello world program. Alright, now let's run this just to make sure everything's working properly. Yep, everything's working. I should probably have the \n there. Yeah, there we go. Everything is working properly. So, to start off, I guess we should start by making some registers. So let's go ahead and make a new folder and just call this lib. Okay, so I guess the registers can just be a struct. Registers. Okay, so we want to make a 32-bit register, whole thing. So a bunch of 32-bit registers. So I don't know exactly how many I want. I just kind of started this stream on a whim, but let's just say 4 to start out. So let's just say you know what? Let's go ahead and make a types.h real quick. So there we go. I want all of the, integer types and stuff. Sorry if you can hear that, that's my dog barking in the background. Let me close my door real quick. Alright, so let's go ahead and make some type defs for all of the integers. So let's start off with the unsigned char and make that a U8. So unsigned 8-bit integer, and then let's do the same thing again, but for a byte. because I might use bytes here at some point. And then a short int, so u16, unsigned int, u32, and then type def unsigned long, just in case it's a 32-bit program, u64, because the minimum size for a long, and usually its typical size, is in fact a 64-bit integer. So just to be safe, I always use long. And then let's do it for the signed ones now. Type def signed char int 8. Type def signed short int 16. Type def signed int 32. And type def signed long int 64. There we go. And then let's just comment these in. Signed 16-bit integer. Unsigned 32-bit integer. And then signed 64-bit integer. And then signed 8-bit integer. Signed 16-bit integer. Signed 32-bit integer. And then signed 64-bit integer. Now this is all we need for right now, but I'm probably going to come back to this and add a whole bunch more. Oops, what'd I do? Nothing, okay. And then let's include that. So lib/types.h, there we go. And now we can go ahead and do u32. Do we want it unsigned? Actually, probably not. But I can probably implement signedness later on. So let's go ahead and name this u32. So A is going to be our accumulator register. And then I guess we're just gonna have B, C, D, and E, and then a couple of pointer registers. Although I guess it's probably a better idea to name them a little bit better. Well, let's just leave it as is. u32C, u32D, u32E. There we go. A, B, C, D, and E is probably good for general purpose registers and accumulator. So general purpose registers. And then pointer registers. So u32. Should I just do like P1 through P4 or something? I feel like that's not a good idea. I guess I could take it from x86 and just do like SIDI and whatnot. So SI. Yeah, I guess so. SI u32 DI, U32EI, there we go. And then U32SP, which is the stack pointer. There we go. And then U32 data register. And then U32 instruction register. There we go. Oh, whoops, don't want that. I just want to indent the comment out just a little bit. There we go. And that's pretty good to start off with, I think. I'll have to probably add more in the future, I don't know yet. Okay. So, I guess to start it off with, let's just say registers.a equals hex 1, 2, 3, 4, 5, 6, 7, 8. That doesn't work. Struct. Ah, right. I forgot how structs worked for a second there. Regs. There we go. Or instead of just regs, yeah, let's just do regs because that's easier. And then regs.a equals hex AA, and then let's go ahead and print that. Percent H, new line. Is it not percent H? What is the hexadecimal operator? C printf hexadecimal operator. Formatting for hexadecimal. X. It's X. There we go. So 0x% x \n, and then regs.a. Boom. And then return 0. Okay. And if we run it, cool. We got it. So that first thing is good. Oh yes, thank you for letting me know. There's a bit of a delay on the stream, but I see you, chatter. I see your messages. Thank you for coming to the stream, by the way. So where should I go next from here? I guess I should implement some ALU functions. And, well, yeah, ALU, so arithmetic and logic. So, I should probably do both signed and unsigned, arithmetic, but in the case of, what is it called? In the case of logic, I probably don't need to specify between signed and unsigned. So, logic. So, should I? No. Probably not. So, yeah, let's do void, and then U32 register. Wait, hold on. U32 probably operand 1, U32, operand 2. Okay. And then this should be pretty easy because C just has the bitwise AND operators. So let's make this return a U32, and then return operand 1, bitwise AND, operand 2, boom. And then U32 not, U32 operand 1. I guess this should check just to make sure it's not an immediate operand. So then return, I can just do not operand, right? Let's not do operand 1 and just do operand. There we go. That would probably do it. Let's make this 0B 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. There we go. And then, not. There we go. And let's see if that works. It does. Cool. Awesome. And then let's go ahead and do OR. I need a return value. OR U32 operand 1, U32 operand 2, and return operand 1, bitwise OR operand 2. There we go. And then U32 XOR. XOR is really important. U32 operand 1, U32 operand 2. Oh, I'm probably gonna have to process interrupts, aren't I? That's something for the future. I don't need to worry about that right now. Okay, so then return operand 1 XOR operand 2. There we go. And then U32. I guess I should go through all the ORs first. So let's do NOR U32 operand 1, U32 operand 2. And then return. Oh, I didn't. There we go. Okay. So, to get a not or, return not or operand 1, operand 2. There we go. That is probably good. Although calling not and then or, calling two functions, that might add a little teeny tiny bit of overhead. But this is C, so I shouldn't be too concerned about that. NOR, and then XNOR U32 operand 1, U32 operand 2. And then return not, yes, not XOR operand 1, operand 2. There we go. And these functions will just make things easier for me, because I could do it when searching for the instruction, but it's probably easier just to put this in. Oh, you know what? Let's go ahead and make the alu.h file and just put everything in there. Okay, so then let's take all of this and put it in here, and then static inline. I believe that's all I need to do. I'm kind of new to header files and stuff, but I'm pretty sure this is all I need to do. So let me finish that up. There we go. The compiler will likely inline a copy of or and not inside of nor for you. Oh, you know what? You're probably right. The compiler is really good at optimizing. Oh, right. These. I need to include types. There we go. Hey, there we go. Oh, looks like I accidentally did that. There we go. Is it still in there? No? There we go. Okay. It resolved on its own. Let's see. I think that's it. So let's go ahead and include that. Include lib/alu.h. And then let's run this again just to make sure it's still working. And yes, it is still working. Okay, let's do and hex 1 and hex 2. Yes, so that should result in 3. Let's see. Oh, no, never mind. Wait, but if it's an and, if it's an and, shouldn't it be 0 because we're doing hex 1 and hex 2? Something's wrong, I think. Hex 1 and hex 1. Oh? That shouldn't be happening. It should become 1. But instead it's doing like an OR operation? I don't know why that's happening. Both first bits are 1. Well, that's what you'd think, but in binary, 3 is 1 1 and 2 is 1 0. And 1 is just, well, 1. So it should return. Wait a minute. Yes, it should return 0. Wait, no. This should return 1, but this should return 0, but instead it's returning 1. And I don't know why that is. Well, time to take it to ChatGPT, I guess. I'm having some trouble with a logic function in C. It's supposed to do a bitwise and, but something is wrong. Here's the function. Can you see anything wrong with it? Okay, so ChatGPT says it's right. But if I do that, why? I guess I need to debug it. Well, that's not going to do anything, but if I put a breakpoint here and then a breakpoint there, let's see if we can find anything out about it. That doesn't mean anything to me. Oh? No, there shouldn't be anything. It's not like it's going to actually affect anything right now. But that's interesting. Okay, so step into. Okay, operand 1 and 2. Okay. And A is still 0 there. Why are we going to not? I'm dumb. I'm just dumb. Yes, thank you. I got it. Okay, yeah. No, I'm just dumb. I'm just dumb. Okay. Let's get rid of that. So it's working. It's working as expected. Yes, there we go. Now it's hex 0. And then if I did hex 1, it's hex 1. Okay. Everything is working exactly as expected. Nah, par for the course. Honestly, yeah, probably. Okay. So from here, I should probably implement arithmetic. Although I'm probably missing a couple other logics, aren't I? Yes, I need NAND. 35 years into C, wow. That's pretty good. I'm only 19 myself. I've only really known C for 6 months now, so I'm still like a beginner. Although I do have a whole folder here, right here, where I'm making a quote-unquote operating system in C. It's not really an operating system, but yeah, I'm making some stuff in C here, and that's pretty fun. But I can't understand a lot of stuff that's going on. I'm just following tutorials, really. So anyway, let's go ahead and... Do ALUs typically have NAND? I've never used it in any of my assembly programs. Do ALUs typically have a NAND instruction? Oh, okay. So there's no NAND NOR or XNOR. I guess I've never used them. You don't really need them, I guess. Those are just logic gate things. The KNRC book, the whole language in roughly 120 pages? Really? That's good to know. I got a textbook from Books A Million here a while back that's all about C++. I've barely touched it because I don't like C++, but hey, you know what? I have it. So, I guess I don't need XNOR. I mean, this is technically my own CPU, but who actually uses XNOR in their programs? So let's just go ahead and get rid of that. So, I guess we don't need NOR either. So we have AND, NOT, OR, and exclusive OR, and I think that's all we need. So let's go to arithmetic. Oh, I'm going to need a floating point unit too. Should I make a specific fpu.h? I might. Static inline u32 u add for unsigned add, u32 operand 1, u32 operand 2. So then return operand 1 plus operand 2. I feel like doing all of these functions is kind of counterintuitive, because I could probably just do that in the emulator file itself, like as it's looking for instructions. But oh well. Static inline int32 add u32 operand 1, u32 operand 2, return. This will let you change from 32 to 16-bit easily. The K and R C book, I've actually wanted to program in 16-bit C, and I did try it a little bit earlier today and a little bit yesterday as well, but I actually found it extremely difficult and easier to program in assembly, actually, in a 16-bit environment. I don't know if other people have had the same thing here, but I just cannot figure out how to use a segmented memory model in 16-bit C. It's like impossible. Like, I just want to get a pointer to the segment pointed to by the extra segment register, but oh no, can't do that. The modular setup that I'm doing is good? Good. I'm glad. It's probably good to have a modular program anyway. Operand 1 plus operand 2. And then static inline u32. Should it be unsigned? Should I separate signed and unsigned addition? Oh yeah, 16-bit memory is a pain. Tell me about it. Holy moly. In assembly, it's actually pretty simple. You just do, for example, ES offset DI, and it writes to that sometimes. But in C, say I did a U8 pointer to hex A0000, which is where VRAM is, or the frame buffer is for VGA, it won't let you do that. Mainly because pointers in 16-bit C are 16 bits wide, obviously, but you know. Gotta go. Alright, see ya, man. I'm glad you could join the stream. Thank you for coming. So let's not defer between these. Hopefully that's not going to come back to bite me later, but it probably won't. Cannot overload functions distinguished by return type alone. I don't know what that's all about, but whatever. Static inline U32 subtract U32 operand 1 U32 operand 2. Oh, you know what? I should probably do source and destination. So I probably want to do a little bit of NASM syntax, or Intel syntax rather. So source. Wait. No, never mind. That's not source. That I'm thinking AT&T. Dest. And then source. So let's go ahead and do that for all of these. There we go. And then change all these operand 1s to dest. And then source. We'll make things more readable anyway. So let's go ahead and finish that up. There we go. That's probably better. So then return dest minus source. There we go. I'm sure that will have absolutely nothing bad to do. I'm sure nothing wrong will happen if I go underneath 0 with an unsigned integer here. Absolutely nothing. And then I need multiplication, so static inline, inline U32, multiply U32 dest, U3, oh wait, hold on. That isn't source, is it? Well, I guess it kind of is, but I don't know, should it be data instead? I feel like it should be data. I don't know. Because I'm not going to be just doing it with registers, because the first one does have to be a register or a memory location, but the second one can be an immediate variable. That's what I want to go for anyway. I guess I'll just leave that as source. I'm sure that nothing bad will come from that. Source and turn dest times source and then static inline U32 div U32 dest U32 source. Cool. I could probably have pointers here instead so that I can just directly manipulate the pointers instead of returning something, but overall probably not that big of a deal. So return dest divided by source. Thinking about it realistically here, I want to do most of my arithmetic operations with the accumulator register, so like multiply and divide, but then I'd have to put the registers somewhere else, and I don't want to do that. I don't know. Registers.h. Hashtag if and def. Registers underscore h. Hashtag define. Registers underscore h. Hashtag endif. Okay. And let's just go ahead and move all of our registers into registers.h. Registers. There we go. And then I need types. There we go. And now include registers.h. There we go. All right. So, I actually don't know why x86 can only do multiply and divide with just the accumulator register and a different one. A different register. It could even be a oh wait, no, it does have to be a register unless it's multiply, I think. I don't know why exactly they wired the CPU to be like that, but that's dumb. So instead of doing that, I think I'm going to keep this as it is because I like it this way. Also, I kind of want to name my registers to the x86 ones. Although that being said, I could get the two assembly languages confused, and that wouldn't be great. I guess I'll just leave it as it is. It's my CPU. I can do what I want with it, right? Okay, let me go ahead and pull up. Hey, Ramder, how's it going? Just you know, making a CPU like normal people do, right? Oh, you gotta go already? Alright, well, you know what? It was fun while you were here. What am I looking for? Hardware. Yes. There we go. Let's see. What was this change log? Oh, yes, RAM. I should probably do that. Since this is 32-bit, let's just go ahead and shove a good old 4 gigabytes of RAM into this computer. So, byte RAM. X 1 2 3 4 5 6 7 8. Yes, good. Darn it, I've always had trouble initializing arrays in C. Is it supposed to be that? Yes. Perfect. Yeah, because 4 is 16 bits, so 8 is 32. Perfect. This should take up 4 gigabytes in my system. Let's pull up system monitor just to make sure about that. So if I go ahead and run the program and just add an infinite loop right here. Good. And now memory. There should be a sharp increase here soon, if this is working properly. It's not. But shouldn't that uninitialized data be there? I don't like how this is looking. Okay, let's try one more time. Nothing. Okay, I'm just gonna go ahead and trust. Actually, you know what? No, I'm not. I'm not gonna go ahead and trust that it's there. I'm going to look up how to initialize an array in C just to make sure that it's what it should be. Oh, no, because I already have that. Bank size, memory bank. Yeah. Okay, so this is in fact how you initialize an array. Okay, so I'm going to trust that this is working exactly as expected. Which probably isn't the greatest of ideas, but oh well. Let's see. I guess now that we have this all set up, the best thing to do would be to add instructions. So instructions.h. This is probably going to be the largest file here. If instructions underscore h hashtag define instructions underscore h hashtag endif. Okay. So, from here, I guess I just need to define all of the instructions. hashtag define nop hex 0. I guess I can go and look through this. So there's going to need to be operations with one operand, with two operands, and with no operands, like nop. I could have it be 64 bits with a 32-bit instruction and a 32-bit operand for just one operand instructions. But I don't know, I feel like that's a lot of memory space. Huh. How do instructions work for CPUs? How do instructions for CPUs get their operands? Or rather, how are instruction operands stored for a program? An operand whose address is stored in the register or in the memory location specified. That's an indirect operand. Computer instructions are stored in consecutive locations and are executed sequentially. Okay, fair enough. This requires a register which can be stored at the address of the next instruction. We call it the program counter. Yup. That makes perfect sense. Oracle Help Center, instructions, operands, and addressing. That might be a good place to go. Yeah, byte, word, long, quad word. I get that. Okay, nothing useful there. Oh, that's right. There's like the fetch execute cycle. There's something else in there that I also need to use, but something like that. Okay, immediate mode operation as part of the instruction is fetched from code memory following the instruction opcode. The operand is a value stored in a register. Yeah. Register indirect, the value is stored in memory and the specific address is held in. Should I have like two program counters, one that points to data and one that points to, well, one that points to operands and one that points to instructions? I feel like that's a really bad idea. Stack addressed pushes and pops using the stack pointer. No. How to implement a fetch execute cycle. The fetch decode execute cycle, that's what it is. I knew it was something along those lines. Programs, yeah, fetch, decoded, and executed. A video. I'd rather not watch a video on a live stream here. Oh, there's like all chapters. Oh wait, these are related questions. Look at this. So fetch, decode, execute. That doesn't. So I guess what I need to do is store the operands with the instruction and just jump over the operands. That would make each instruction like what's 32 plus 16? 48. That's 48 bits. I mean, it could certainly be worse, and I mean, we have 4 gigabytes of RAM, but I feel like there's a better way. How do I store operands with an instruction and it is loaded into RAM? Do I just put the operands with the instruction? Operands are typically stored separately from the instruction itself, okay? The CPU fetches instructions from memory RAM sequentially or as directed by the program counter. Decoding, once it's fetched, the CPU decodes it to determine the operation it needs to perform. Operand fetch. It may need to fetch operands from memory or from registers. If the operands are in memory, the CPU will fetch them from their respective memory locations. Okay. So that tells me that there are different instructions based on registers, memory, and immediate. So I guess I will go ahead and try and see if I can do that. So I guess instruction operands will be stored with the instructions, and with each increase of the program counter, it'll just hop over both operands. And I mean, that's a lot of space, but oh well. It is what it is. So, to start off, let's see. I guess we can start off with ALU instructions. So add immediate hex 1, 2, 3, 4, 5, 6, 7, 8. Hashtag define add register hex 1, 2, 3, 4, 5, 6, 7, 8. And then define add memory. That being said, there's also combinations between the first one and second one, because in my original CPU architecture, you could only do immediates and registers, and a pointer register could do stuff with memory. So it was always either use a register or use an immediate operand, and all logic and arithmetic operations ended up in register A. But I don't want to do that here. So, I mean, if I hard-coded all of these, that would be more of a complex instruction set, and I don't really want that. I want a reduced instruction set. So I guess I'm going to have to get rid of that and instead have it... No, because I need to specify. But how can I do that? Okay, I guess this can say what the second operand is, and then the first one can be anything, maybe. I don't know, this is very difficult. I didn't think it would be this difficult. Let's see what ChatGPT has to say. When designing a CPU, how does the instruction change based on whether it is a memory location a register or an immediate operand being operated on. The instruction format typically includes fields that specify the operations and operation to be performed. These fields may indicate whether an operand is a memory location, a register, or an immediate value. Here's a general overview of how the instruction format might handle different types of operands. Register operand, memory operand, immediate operand. Oh yes, I could do like R1 through R4 if I really wanted to. Considering how I want to make this, I think I can do R1, R2, R3, R4, and R5. There we go. That's probably good. Immediate operands are values that are included directly in the instruction itself. This could be a constant value that is used as an operand for an operation. The instruction format would include a field to hold this immediate value. Okay. So, I guess the first couple of bits should be flags. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, so these two could be the first operand, and these two right here could be the second operand. So let's just say first operand is a register, first operand is a memory location, first operand is an immediate value. And then same thing with the second one. So register, memory location, immediate value. Something like that. So then, instead of making this hex, that's going to be huge though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, 1, 2, 3, 4. Like that. Which, I mean, I guess that'll work. Let's go ahead and copy this whole thing. And define sub, and then go ahead and do that. But instead it's 1, 0. Define mul, then 1, 1. Hashtag define div. And then 1, 1 right there. That one should be 1. Hashtag define and then or right, okay. So then 1, 1, 0. Define XOR. There we go. Oh man. This might be a bit difficult. Okay, so we have OR and then XOR. Oh, I guess we should have the move instruction. So then hashtag define mov 1 2 3 4 1. There we go, just like that. Good, still an int. All these are int, good. Hashtag define LEA, so load immediate address. 1 2 3 right there. And or XOR. Oh, I forgot not. Well, I'm just gonna put it under this. Not 1 1 0. There we go. And then define oh right, we're gonna need bit shifting. Shift left. And then 1 1 1 0 1 1. That's exactly what we want. And then define shift right. 1 2 3 4 1 1 0 0. Good. Shift left, shift right. And then we're going to need jumping and branching instructions. So then define JMP. Okay. So 1101, 208 versus 192. Perfect. Hashtag define jump if equal. Just like that. Define jump if not equal. I think that's exactly what we need. Let's see. 224 to 240. Wow. I guess that's exactly what I needed to be. Jump if not equal. Yeah, I guess I should also have jump if greater or less than. And jump on overflow. So let's do that. Define. Oh, I need a flags register. U32 flags. There we go. And then let's make some quick booleans. Type def u8 bool. Hashtag define true 1. And then define false 0. There we go. And then over in registers, bool flags. There we go. Well, I guess that should have a specific size. Let's see, what flags do we want to have? Overflow. let's see. What other flags do we need? What flags does a CPU need? We probably only need a few of the most common flags. Oh, yes! Carry. We might want carry. So, carry. Zero. Sign. That's probably going to be a good flag. Ooh, an interrupt. Yes, I'm probably going to want a few interrupts. Give me just 1 second. I'll be right back. Just need to do something real quick. Alright, I'm back. So, anyway, let's get back to all these flags. Let's see. Trap flag, what is that? Permits operation of a processor in single step mode. Don't know what that means. Hopefully that doesn't mean anything important. Already got overflow. IO privilege level, that's not a big deal. Mode flag. NEC 5. NEC 5 series. Probably not that big of a deal. Resume flag. Virtual mode? Oh, like, yeah, real mode applications are incapable of running directly in protected mode. Okay. I don't need that. Virtual interrupt. CPU ID. Oh. Probably don't need that. Alternate instruction set. Don't need that either. Okay. So, 1, 2, 3, 4, 5. 5 flags. That's probably good. So let's go ahead and make that 5. I'll probably add more if and when I need them. So, jump on overflow. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4. There we go. 256 versus 240. Perfect. And then define jump if 0, which needs to be that, and then jump if not 0, 1, 0. Yes, okay, so it should be that one. Yes, perfect. That's probably good in terms of conditional jumping. and jumping. I mean, I rarely use anything outside of this group right here, so that's probably good. Alright, so from there, let's see. Those are load and store instructions, which will be replaced with the move instructions, so that's fine. Oh, push and pop. That's probably something I'll need. Okay, so define push. Okay, 1 1. So 1 0 0 1 1. Hashtag define pop. And then 1 0 0. So it should be 1 0 1 0 0. Perfect. 304 320. Perfect. Okay, that should do it. Push, pop. Oh, increment and decrement. Yes, that's probably good to have. Define increment. 1 0 1 0 0. 1 0 1 0 1 is what's next. Define decrement. And then just swap that. Perfect. Increment, decrement. Those are logic. Okay. This instruction set's actually pretty small. Is that all I need? There's got to be more. Let me pull up an assembly file here. Oh wait, that's for my custom assembly language for my 8-bit processor. Let's check out my 16-bit assembly program here, the one I made on stream a while back. Okay. Don't need segments. We have the move instruction. Oh, we're going to need register bits, aren't we? Like half registers and stuff. I will wait until the future to get that. Oh, we need an interrupt instruction though, don't we? Let's go ahead and get the interrupt instruction. First I define int. Okay. 1 0 1 1 1. Yes, that looks like exactly what I need. And then, do we have a direction flag? No, we don't need a direction flag. I don't even know what the direction flag does, so hopefully it's nothing important. In text 10 right letter. Let's see, what else do we need? Labels and stuff will be for the assembler. Oh, we're going to need widths, aren't we? If we want to use more than just bytes. Ah, that's going to be a whole thing, isn't it? I'm going to let the assembler handle that much later on. And that's probably not something that'll go on in instructions anyway. Actually, regarding that, in AT&T syntax, it's actually, instead of inc word, it's just inc w. Same thing with like move w and stuff. So that might be something to think about. Because, like, are they separate instructions? Because if so, that's a really big deal. Well, let's go ahead and say, let's go ahead and leave it B for now. Interacting with just individual bytes of memory is not going to be a great idea. But doing it as an abstraction on the assembler side is going to be crazy hard. Well, flags. Okay. So, 0001. Wait, hold on. It needs to be like 0101. Register 1010. Memory 0111. Register immediate 1011. Memory immediate. Okay. So I guess I could do byte and double word in terms of this. Like, you know, 10 being a memory flag, and then 11 being whatever it's called. Not a memory flag. Oh, right. 10 being to write to a byte, and then 11 being to write to a double word. But I feel like that's not a good idea. You know, people might want to have 16-bit values. Okay. I guess I'll make it not for memory. There we go. Or rather, not for storing to memory. So if we were going to load from memory, I have an idea. Why don't we make a load instruction? Define load. So I'm just going to take this one and paste it there. And then 1, 2, 3, 4. Okay. Loads from a register or immediate value to memory. Okay. So then 0101 equals. Okay, so the source is this one right here. So byte register 1001 equals word / register, and then 1101 equals dword / register, and then 0110 equals byte slash immediate. Is 10 immediate? No, 11 is immediate. Okay, 1010 equals word slash word. And then 1110 equals dword slash dword. And then 0111 equals byte slash immediate. 1011 equals word slash immediate. And then 1111 equals dword slash immediate. There we go. That's probably pretty good to start off with right here. Okay, perfect. So that specific load instruction will help circumvent a lot of the problems around the mov instruction. So hopefully that will be all I need to use. One sec. Alright, I'm back. So, from here, I guess that's all the instructions we need to start out with. I can't think of anything else off the top of my head. I'll probably come to it in the future. There will be floating point instructions here at some point. Apologies for the dog in the background. Okay. That's R1 now and not A. There we go. Unknown name bool in registers.h. That includes types.h, so... Ah! There we go. That would do it. I think that's just a thing that it does. I'm gonna ignore it. It should be working. Yes, it is working. Cool. And now I guess all I have to do is process the instructions. Well, all I have to do. Obviously there's going to be a whole lot more than that because the processor has to go through everything. But let's start it off here. So void process instruction U32 instruction U32 operand 1 U32 operand 2. There we go. And I probably shouldn't do a bunch of if-else statements, but a switch statement uses breaks, and I'm pretty sure breaks produce overhead. I guess I should ask. In C, does a switch statement produce more overhead than a bunch of if statements? However, generally speaking, switch statements can sometimes be more efficient than multiple if statements, especially when there are multiple conditions being checked against the same value. Okay. Okay, awesome. I don't quite remember how exactly to do switches, so I'm gonna have to look that up. How to make... Oh, wait, hold on. I can just ask ChatGPT for an example. Can you provide a quick example of a switch statement? Okay. Switch instruction. And then, yep, brackets. So then case instruction equals add. I forgot about that. I can't name the instructions the same thing. Let's just put an A in front of all of them. I'm sure that'll be fine. There we go. Nothing wrong with that, I'm sure. Okay. I don't have instructions.h. That is probably what's wrong. Include lib/instructions.h. There we go. Ooh, he's streaming? I am. My dog is barking incessantly, and I don't really know why. Expression must have a constant value. Does it have to be that instead? No. Okay, so in the case instruction equals add operand 1, operand 2. I need that A right there. There we go. A add operand 1, operand 2. And then, yep, I can just keep going on with the cases, but I do need break. There we go. Case instruction equals subtract. A sub operand 1, operand 2. Okay, and so let's process instruction add eggs.r1, or I need that A. Oh wait, no, never mind, I don't need that A. Eggs.r1, and then 2. And let's see if that works. Okay, I currently have this, but it doesn't seem to be working. What can I change to fix that? The syntax you're using in the switch statement is incorrect for achieving what you want. In a switch statement, each case should be followed by a constant expression, not a condition. Oh, okay, so I do have to use if else. This is going to be a big if else statement. Okay, so if instruction equals add. Oh, you know what? I should probably hashtag define reg 0b 0101 hashtag define mem 1010 define reg immediate 0111 define mem immediate 1011. Okay. I need the 0b. And then I probably also need more of them. So there's register, and then memory, and then register immediate. Okay, so we need register, memory, register. Okay, so define mem 0110 define mem reg 1001, and I think that's all of the options. Okay, and then I need to bitwise or add with register immediate. There we go. So if instruction equals add, and if instruction or reg immediate add rather operand 1 operand 2 okay. This technically does have a return, but I guess I don't need that. Okay, I need to get hex codes for registers. So define code R1 hex 1 code register 2 hex 2, and just the same thing for all the registers. Define code R4 hex 4 hex 5, and then hex 6 di hex 7 EI hex 8. SP is hex 9. Code data. Oh wait, we don't need the data and instruction register. So I guess that's exactly what we need. Perfect. Okay, so from here, now that I can get the registers, let's go ahead and do code for register 1. So then, get register operand 1. Okay. What's that all about? Case label does not reduce to an integer constant. Okay, that's not there anymore, so I'm just gonna void get register U32 code. Oh wait, that's not void, that's a U32 pointer? Yeah, I think that's a U32 pointer. And then if code equals code R1, return at regs.r1. I guess this needs to be outside of main. That was probably a given already, so let's just put that up there. And that needs to be uppercase. There we go. And then else if code equals code R2. And then I can just paste that right there and get regs.r2. And this is going to take a while. And then 3, add 3. And then good old 4 and 4. And then 5 and 5. Cool. And then instead of R, let's see, SI, DI, and EI. SI, and then EI, and then DI. Perfect. Okay. And then a pointer to U32 register equals register and then operand 2. Or I guess we should do reg. There we go. And I think that's all it needs. Let's see. That's not what I need. I just need to click this. Oh, I need the pointer to the register. Line 32. Why can't I do this? I'm going to have to ask. Why can't I use the following C code? Instruction is an integer variable, and regimm is a constant defined with hashtag define. This operation does not check whether it is equal. Instead, it combines the bits of... but I don't want to tell if it's equal. I want to know if regimm is a part of instruction. How can I do that? Ah, the bitwise AND operator. I was thinking maybe that's what I needed. Nope, not that. I'm so used to doing that. 32. Still same. Invalid combination of type specifiers. Come on. Really? Do I really need to make it like as big as possible? 1, 2, 3, 4. I need 28. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Perfect. And now I can just do that for all of these. Boom. Let's see. 5, 10, 6, 9, 7, 11. Okay, all of them are different. Good. What do you mean? Invalid combination of type specifiers. Okay, so clearly the issue doesn't exist, apparently. It's not compiling for some reason, and it won't say why. Like, oh yeah, invalid combination of type specifiers right here. Yeah, that makes sense. Yep, line 32. On column 23. I don't know, maybe I'll just put a cast there and... Wait a minute. So I need to do some bit shifting. 4, 4. There we go. Shift it right 4 to get rid of the first 4 bits. Where is it? Right here. The first 4 bits, and then shift it right again to, or shift it left, sorry, again to get it back to where it originally was. Okay. What? Oh, types.h. Wait. Huh? Okay, but bool isn't a type in C, is it? I mean, I guess I don't need it right now. Whatever, if it works, I guess. No, yeah, I thought that bool wasn't a type in C, so why is it doing this? Why does the compiler hate bool so much? No. Invalid combination of type specifiers, thanks. But that doesn't make any sense. Okay, that works. There. Okay. I see. I see. What is happening? But there's no, like, reason for it to be like this. I don't know. I guess I'll just disable error squiggles. There. It's working. In function get register. So I guess instead of that, Huh. I think the problem is this. Struct registers. Maybe that's the issue? Huh. In a C function, how can I return just one item in a struct? You cannot directly return a single member of a struct from a function. When you return a struct from a function, you are returning the entire struct. However, you can return a single member of a struct by encapsulating that member within a struct itself. I want to return a pointer to a specific item in the struct. How can I do that? That returns a pointer to that member. Okay. So then, it should be this. And then, Okay, I'm just gonna copy this function and paste it into ChatGPT and see what it has to say. Here is what I currently have. Does it work? It looks correct, but is missing return statement for cases when none of the if functions match. Oh yes, else return null. There. Okay. Time to make a makefile. This is stupid. Makefile. GCC dash elf64. I think that's how I do it. I don't know. I haven't compiled with GCC from the command line for a while. So compile run all compile run. There we go. L64 search / emulator .c -o emulator .o. Okay, I think that's all that I need. But we can do bin / emulator.o, and then build, or we need to link it. LD bins. Oh, right. So instead of bin, it should be build / emulator .o -o emulator dot or just emulator. because I don't need a .bin, but I do need to put it in bin/emulator. And instead of build, bin/emulator. There we go. Make. Okay, that's not how you do it. I believe that's default, so let's just go ahead and see if we can do that and get away with that. In function get register. Let's do -w for both of these and see if that still comes up, because if it does, yeah. But what was the error? Are these the actual error? Okay. What happens if I do that instead? That might be the issue. I don't know. Oops. Let's see. Nope. Okay. Okay, I don't know what I'm missing here. I mean, do I just not put it in a struct then? But that's so useful. Okay, yeah, but it's clearly not letting me do that. What if I remove all those addresses and instead just do this? Nope. Basically the same thing. Man, I hate it when it does this. This is so dumb. Why can't it just return this? Alright. Guess I'm not using a struct. Come on, I used tab, don't even say that. No more struct registers. Alright. Here we go. Now I have to do this. most tedious part of any program is doing stuff like this, honestly. There we go. Alright, now let's try it. Oh. There we go. No problems. Finished with errors. What? That returns the address of register 1, and this is a unsigned 32-bit integer pointer. So then what's the error? An unsigned 32-bit integer, a pointer to an unsigned 32-bit integer. Right. What the hell? Okay. I've just decided to go with this, but it still won't compile with these errors. Copy and paste. What does it mean? How do I fix it? Your message you're seeing indicates that the linker is encountering relocation errors, which suggests that there's a problem with the size of the code being generated. This can happen when the linker tries to fit too much code into a segment of limited size, often caused by excessively large static arrays or uninitialized variables. Ah! It's this. I bet. Oh, they're placed in the .bss. I see. To resolve these issues, you can explicitly initialize the variables. Aha! I see. So there's a problem with, you know, the very tiny 4 gigabytes of reserved data that we have. That will definitely do it. There we go. Now, I probably need to do it to this too. One, two, three, 4, 5. There we go. And then run. Access elements in scalar initial. What? Uh-huh. What does this mean? Yeah, I mean it's a quote unquote macro defining that false is 0. What else do you want? What the hell is the compiler on about today? It's not usually like this. Like usually this stuff works, but now it's like not. I don't know. What happens if I just get rid of that? Oh, the dash W. Let's get rid of that. Excess elements in scalar initializer. What do you mean? What does that mean? There aren't any access elements. That's it. That's all there is. It is literally just 0. That is the entire macro. The entire macro is 0. But there's too many elements, apparently. Does it just want an empty macro? Like, what would happen if I just did that? Yup. Okay. There. Okay. So, now that it's actually working, let's go ahead and, step through this, see what's going on. Instruction 23. Okay. Okay, good. That adds 2 to it. No, that's not what I need. Okay. So then why does it print hex 0 if it gets all the way to the end of the program? That's correct. Because that does in fact point to the register. What happens if I do that? That's not going to work. And that still is 0. Okay, operand 1 is 1, as expected. Yeah, okay, so it adds the value. It should be the value at the address if I do this. Correct? Okay. Good. Ah. Perhaps I should do that. Let's go. I did it. First instruction is working. Hooray. But we still need to get that RAM working. Yes. Yeah, because that only has problems when I have that exceedingly large array. Which, I mean, it makes sense. It makes sense, let's be real. I guess we don't need 4 gigabytes. Let's just do 1,000 million billion. There we go. 1 gigabyte should be fine for now. Let's see if that works. There we go. I guess 4 gigabytes is a little bit much to have in a file. Just a teeny tiny bit. Okay. So else if instruction and reg we're going to need to do this. Register 1 and register 2. There we go. And then register 1 equals add register 1 and register 2. There we go. And then I guess we can just have returns after this to make it run a little faster. Else if instruction and where is it? Okay, let's get rid of all of this excess stuff now because clearly we don't need it. Okay. Register immediate, register, and then register memory. Okay, and we need RAM with the index of operand 2. Yes, and considering it's a register, it will immediately use a D word, although I don't know if that's a good idea. Well, hopefully it'll be fine. Oh, I can 1, 2, 3, 4, 5, 6, 7, 8 equals 0. Perfect. Let's see if it still works. No. Okay. Let's just leave it as it was then. Yep. I guess I'm gonna have to figure out a way to fix that at some point here. Yeah, okay. Else if instruction and okay, yeah, we already have all that, so let's do mem em. How about mem? Mem. There we go. And then RAM operand 1 equals add RAM operand 1 plus RAM operand 2. Oh, that parenthesis does it. Oh no, it does. It does. Huh? Oh, whoops. There we go. And then else if instruction and mem immediate. And then let's just copy and paste, except just operand 2. There we go. Oh, I need the returns. Oh, man. Gotta be honest though, all this 4 gigabytes coming and going, that is probably obliterating my SSD. Although this is a USB SSD, the main operating system on this is Windows, so I guess it's not the end of the world, but I'd rather keep this entire operating system. Else if instruction and mem, and then memreg. I could probably just paste that, and then get the register out of operand 2. And then there we go. Is that all of them? Register, memory, register immediate, memory immediate. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Perfect. We don't need to worry about load yet. Yeah. Because we're just doing ALU right now. So, process instruction, add bitwise OR, register immediate, code R1, and then hex 5, and then let's go ahead and take this and then make it subtract hex 2. So it should come out as hex 5. It's hex 7. Because I haven't implemented this yet. I haven't implemented subtraction. That would probably do it. So hex 7 is exactly what we should be expecting, which is great. Let's instead do register, and then code R2. Okay. Hex 5, hex 7. It should be B? Hex 9. Okay, so this makes this hex 7, and then this adds hex 5 to register 2. And then this adds register 1 and register 2. And register 1, which will already be hex 7. Let's put a breakpoint all along this and see what's going on. Okay. Good. And then adds good. Well, maybe. Operand 1 is 2. And operand 2 is 5. Which is exactly what we need. Okay. Okay, it's 1 and 2, which is exactly what it needs to be. It specifies it as register immediate. 111. Are there any other 111s? No. This is 101. Oh. Okay, so it does never get here. But this... Zero, 111, 0101. Okay. Okay, the instruction is 21. Uh, 17, 18, 19, 20, 21. Okay, it needs to add 5, which is register register. Okay. So then this should not be true. But it is. Why is it true? Huh. But why is it true? Oh, I see, because this can still in fact be true. Uh-huh. I see, I see. So then, what happens if I switch them? Still hex 9. Because I'm doing it wrong, duh. First of all, those need to go there. And these need to go right up there. There we go. Hex 0. Yep. Huh. Wait, but those shouldn't... That's very, 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 very strange. Because this should not be true, because they cannot be bitwise ANDed and get true if either one of those are true. Yeah, it's 21. Still 21. But why is it true? That's hexadecimal and not binary. But this should not be true, because this cannot have a bitwise AND with this. I don't know, man. That's so weird. And that really should not be happening. Okay. And now it's going through it every single time. What, dude? How is that even possible? Because they are not equal. Like, their binary is fundamentally different, so bitwise AND should reflect that. Because their binary is literally different. I mean, I can't fix something that isn't a problem. Like, I'm 100% sure there is nothing wrong with this. 100%. I don't know, I guess I'll send it to ChatGPT, see what it has to say. I currently have this C function but for some reason it never gets past the first if statement no matter what I or not the first, but rather the second if statement, no matter what I do. Why is that? How can I fix it? Here are some of the values used. It likely stems from how you're checking the instruction bit patterns. The way you're using bitwise operators and to check specific bits might not be working as expected. Okay, I'm just going to copy this entire function and see if it works, because that would be absolutely awesome if it did. The function looks very nice as well. Let's see. And run. Nope. Okay, never mind then. The problem is, for some unknown reason, the program seems to think that 0B0111 and 0B what was it? 0101 are the same, and so the AND operator returns true when comparing either of them with the instruction. And so the AND operator always returns true when comparing either of them with the instruction. I see. Zero. Okay, hex 5, hex A, hex 6. Wait a minute, was that hex 6? That was hex 6. Hex 9, and that's 9, right? Yeah. Uh, 7. And then B. Yep. Okay. Still getting hex 9. Okay, what if instead I did 1, 2, 3, 4, 5, 6. There. Can't go wrong with 1 through 6. You can, apparently. What? I don't know. I'm just gonna restart this. Maybe that's the issue. Let's go ahead and restart Visual Studio. Still hex 9. I mean, it shouldn't be. Darn. Oh, they're right here. Let's go. It won't let me update this automatically, and honestly, that's a crime. I don't know. I mean, I don't know. Like, this isn't even my fault. Like, how do I fix something that has nothing to do with me? Like, this is literally just the compiler saying no. Like, what can I do about that? Like, should I, I don't know, increase the optimization level? I don't know. I feel like that would be counterintuitive, but I guess it's worth trying. Huh? Ugh. Well, I think for tonight I'm gonna call it here. Because I mean, I don't see any solution at all. Like, I mean, how do I fix something that cannot be fixed, you know? So, yeah, I guess, thank you guys for watching. I appreciate, you guys, especially the people that were here for the whole time. Yeah, I guess that's about it. See you next